Hello! In this video I will be refurbishing a Dataflyer Express hard drive controller and memory expansion for the Amiga 500. I bought this Amiga and expansion from a friend who was the original owner. He bought it sometime in the early 90s. This Dataflyer accepts SCSI or IDE drives, but I believe it's missing a couple of IDE logic chips. It currently has a Quantum Pro Drive ELS, which was a huge 120 meg drive. It also accepts RAM expansion boards up to 8 megabytes, but here it is equipped with only 2. I will be cleaning up the case a little and fix or replace what's broken inside. I apologize for the static shots. I decided to video this after I had started the project, but fortunately I did have a few pics from the case rebuild. All it needed was a little cleaning and touch-up. Also, there were a couple of wrinkles in the metal on the bottom. This happened around the drive mount holes from a poorly mounted hard drive. The drive was mounted with only 2 long screws and 2 standoffs. More on this later. There was some small areas where the paint had flaked off. I decided to do a little touch-up. After mixing paint on a palette until I was close, here is the result. After testing the memory and finding that it worked, I went about identifying it so I could buy more. Unfortunately, the RAM was not marked very well, and Googling the chip numbers gave 0 results. I did know they were 1 megabyte sticks by this jumper on the Dataflyer, and I counted 30 pins. A quick eBay search and a few days later resulted in 4 more megabytes. Here in Workbench I did a memory test, and you can see the test passed and the 6 megabyte total. Here we have the Dataflyer and its barely working hard drive. It doesn't want to spin up reliably, so I have it on external power. The Amiga 500 powering a hard drive through the expansion port is iffy, but even with external power it wouldn't spin up. The scsi2sd, however, will draw a lot less current. And here we have one that just came in the mail. It's a version 5.1 board, and I ordered it with an SD card and a Molex adapter. The power connector on this new board is floppy style, and I knew I would need the adapter. So now it's time to go to work. First things first. This expansion came with no software, and I was somewhat concerned with acquiring the correct drivers. The closest thing I could find was a version 3.7 Dataflyer driver disk. To hedge my bet, I want to get the old hard drive working again so I can get copies of the driver files. I remember hearing about a trick to get an old hard drive working again, temporarily. Well, that worked. After booting up, I opened sysinfo and examined the hard drive device driver. I also verified the SCSI ID and other information in case it becomes relevant. I also opened Hard Drive Toolbox, which is the Amiga OS's built-in hard drive utility. I guess only Commodore controller ROMs will appear here. I then went to the system's startup sequence to look for anything unusual. It was pretty standard. Lastly, I inserted the Dataflyer version 3.7 installation disk that I found and looked at the install batch file to see what files I might need. I wrote the locations and names down and copied them from the existing hard drive to a spare floppy disk, just in case. So this is a version 5.1 scsi2sd. Looking it over, it seems to be made very well. I believe this will last decades, which is great for giving new life to an old computer. To set up the scsi2sd, plug its USB connector into your PC. You can see it get recognized without issue in Windows 10. Proceed to the scsi2sd wiki for downloads and instructions. They use code circ. Code source? Immediately you see a picture of the version 5.1 and version 6 boards. Scroll down to the download links and select the link that matches your version. The links take you to what looks like an FTP site. Download the firmware for the board and the utility for your PC's operating system. Click back and we will scroll down and look at this table that compares the versions of the SCSI2sd boards. Here's the version that I have. I did not select the version 6 board because the A3000 is the only Amiga listed in their compatibility list. I'm sure it will support others, but version 5.1 is fine for my purposes. Just below there is a list of places to buy these boards. There is only one USA link in the distributor list, Inertial Computers. So I ordered from them. I had no trouble ordering or receiving my unit, so I can recommend them as a good source. Scrolling down to the bottom of the page, you will find the links for the FAQ and the user manual. Here is what the SCSI2sd utility looks like. Before we proceed, I would like to talk about partition and drive sizing. This is one of the really cool things about the SCSI2sd. You create virtual physical drives of specific sizes. These virtual drives will be recognized as separate physical hard drives with their own SCSI IDs. I'm not sure why this software limits you to 4 when the SCSI standard supports 7, but I don't think I'll ever need more than 4. As you can see, there is a debug window that lets us know that we are connected, and it shows that the firmware version is already on the latest. Not surprising considering the board is brand new. The included card came with one 2 gig drive, and here you can see the settings. I'm going to add a second 2 gig drive. Each drive will have one partition. Keep in mind the limitations of hard drive partitions. For instance, there is a 4 GB limit to the size of partitions when using a 32-bit file system. Hard drive controllers can have their own limitations, so keep that in mind as well. For the purposes of this video, I will stick to 2 gig partitions, but using newer file systems and hardware would obviously get you larger sizes. So here's the existing 2 gig drive set up as SCSI ID 0. Here is the number of sectors that this hard drive occupies. First, I'm going to copy this number to the clipboard, then I'm going to select the second drive and enable it. It starts at sector 0, which is an overlap because that is where drive 0 starts. Here, you see me paste the number to the start sector. I was an idiot and incremented the number by 1. This was unnecessary because the previous drive starts at 0. I could start the next drive at 4194303. Now we simply need to save the configuration to the device. Okay, let's plug this into the Dataflyer and try the Dataflyer install disk. And here we see that it sees the 2 virtual drives. Let's click on Install on the first one. I just repeated the process with the second drive. It's a pretty speedy process. Well, here are the drives, but what is this? Reserved. I'll check some sizes here. That's strange. What the heck is reserved? Maybe they'll disappear after reboot, I don't know. Let's try this next, install drivers. Whoa, I'm not sure what's going on here. Let's just try a reboot and boot from the Workbench install disk. Well, after booting from the Workbench 2.1 install disk, we can see that those reserve drives have indeed disappeared. Let's try to install Workbench. Now make sure the disk is out and reboot. And we will boot from the hard drive for the first time. The system seems to boot fine, and it's pretty fast. And we can see the free space left on each drive. The hard drive activity light works on the scsi2sd, but it doesn't work on the Dataflyer. I have tested this LED and it does work. The scsi2sd doesn't have a header plug, but it does have a place for one. It even has an SMD resistor for the external LED, labeled R305. I bodged a couple of jumpers to test the LED on the scsi2sd. No problems there. I just need to get a pair of header pins cut and fitted to the board. The original method in which the LEDs were held into the case was poor, just glued to the metal, and of course that failed. These are the LEDs that came with it. They don't match each other. This one kind of looks like it probably was the factory one. It's got a little notch in it, but it's kind of busted. They both work. This one, however, is your garden variety stepped lens LED that looks like it was glued in there. Obviously it's a good reason to replace. I 3D printed some lenses in clear ABS plastic that fit snugly into those holes. And then I made a black ABS bracket to fit over that and also hold new LEDs in place. Now we will clip off the old LEDs and replace them. I have an assortment of LEDs around that will be close matches for the red power indicator and the amber hard drive. These old wires required flux to get solder to stick to them. I am playing this footage at elevated speed so we don't all fall asleep. Also, I am only showing the procedure for one LED. The other I did off camera. I'm now using a heat gun to shrink the heat shrink. LEDs these days are all the same translucent color when they are not powered up. I wanted an easy way to tell which one is which, so I'm putting an extra piece of red heat shrink on the power LED wire. Let's give this thing a test, shall we? This is a case where I'm going to use two different kinds of glues for two different purposes. I'm going to use permanent super glue, CA glue, to glue this black plastic piece to the lenses to make it permanent. However, the LEDs themselves, I'm going to glue in with white glue so that they're easily removable if they burn out. The board is not quite the same size as a standard hard drive. The holes make no attempt to line themselves up. Looks like I will be making an adapter bracket with my 3D printer. Okay, so I 3D printed a bracket, and the way I made this was I made this frame, this outside frame, and then I made these posts or spacers separately. They're a place for the screws to pass through. And I usually make things to suit the hardware that I have, and well, frankly, these are actually the correct drive screws. So this is the correct size. Now these are spacers, so there's the screws fit in and slide in, and then there's holes in the bracket which are a little bit smaller, and the screws will actually thread through there. So it was a bit complicated. I went for a plan as far as gluing these in the exact right spot where they needed to be. I stuck a couple posts in there and put the screws in them, and then put some glue on them and on the posts, the spacers, and then I placed this down and actually tightened it down. I believe I did the back two first, and then when the glue dried, I took those screws out and removed the bracket and did the front two. I put the post in there, the post in there, and put the screws in, and then brought the bracket down and put all four screws in, and then waited for that to dry. And in the end, we have a nice secure place for the SCSI2sd to sit. I was fairly successful with my 3D printing, with one exception. I didn't account for how the case fits together, and I had to trim the plastic a little to fit. It took me 1 minute with a rotary tool. One final look and boot up after completion. By the way, the boot up sequence I'm showing now and the previous one were in real time. The scsi2sd is really the best way to replace an original SCSI hard drive. And this is actually the second one of these A500 sidecars I have rebuilt with a scsi2sd. The previous one was the Commodore branded A590. That one went on to a hopefully good home via eBay. I'm also using a scsi2sd in my A2000 that you may have noticed sitting under the monitor in this video. Thank you for watching.